Now we proceed to illustrative example number 2. Here, we are asked to write the same series 3 plus 7 plus 11 plus 15 plus 19 in sigma notation. But the difference here is that instead na ang gagamitin nating minimum value is 1, we will use 2. Now, what will be the effect of using a different minimum value? So, meron tayong, may dalawang parts na affected. Affected yung maximum value natin. Also, affected din yung ating magiging general expression later. So, kung kanina ang ating minimum value ay 1, tapos we ended at 5 as our maximum value dahil parang ang correspondence ay 1, 2, 3, 4, 5. Now, dahil we will start at 2, we will end at 6 because this term here corresponds to 2. Kaya we start our counting at 2. So, if we start at 2, we will end at 2, 3, 4, 5, 6. So, we will end at 6. So, our end here is 6. So, that's obvious. Now, it will be more obvious if we will tabulate our information, our given data. So, 2 corresponds to 3, 3 corresponds to 7, 4 to 11, 5 to 15, and then 6 to the last term which is 19. Now, hindi natin pwedeng gamitin yung formula. We cannot directly use the formula for arithmetic sequence, though we know this one is an arithmetic sequence, because this formula requires that n should correspond to the position of the term. And that, dapat mag-uumpisa yung position at 1. Here, we start at 2. But, just because it's, it doesn't mean hindi natin na siya pwedeng gamitin. We have to do a simple manipulation here. So, if that's the problem, na hindi nag-start yung ating positions, yung I sa 1, then we can start at 1, di ba? And by starting at 1, we reveal that the number or the term that should correspond to 1 is negative 1. Bakit? Because, you see, we have to move 4 steps to the left of 3 on the number line. Diba? 7 minus 4 naging 3. So, kung maatras pa tayo rito, we also have to subtract 4 from 3. It's like moving 4 steps to the left of 3 sa number line. So, that is 3 minus 4, and that will be negative 1. So, here now, na-satisfy natin yung condition ng formula na dapat mag-start yung position sa 1. And, if so, yung a sub 1 natin should be negative 1. So, using the formula, a sub n is equal to a sub 1 plus the quantity n minus 1 closed quantity times b. Mahanap natin yung a sub n of the expression, and that is 4n minus 5. You see, it's also affected. The f of I, the general expression, is also affected. If here, we have 4n minus 1, here, we have 4n minus 5. And I hope you notice a pattern. So the answer here is the summation of the quantity n minus 5 at from 2 to at I equals 2 to 6. And we say na this expression is equivalent to the expression na nakuha natin sa illustrative example 1. They are said to be equivalent because they they express or represent the same series. Now, can you think of any other way to reveal the f of 1 ng isang series when the given m is not equal to 1. You see, that's the challenge. Pag hindi 1 yung m natin, then we always have to find our f of 1. What if hindi lang m equals 2, di ba? What if ang binigay sa atin na m ay 10? Meron bang shorthand? Can you think of a shorter way para mahanap yung f of 1 without necessarily constructing a table of values? Or what if m is negative 8? Paano kaya natin malalaman yung f of 1 nung given na series, nung series? Okay, so pag-isipan niyo yan. But to have a hint, you may look at the equivalent expressions here. They are equivalent, but may mga certain differences dyan na ma-observe niyo na may pattern. Look. Okay? Now we proceed to our MEP 15. Here you are expected to be able to apply the use of sigma notation in finding sums. Now, what's marvelous about certain types of series ay nag-generate talaga ang terms natin using patterns. And because of that, minsan, madaling i-evaluate. I mean, hindi naman sa madali, kundi may convenient techniques para ma-evaluate natin yung ilang expressions without necessarily entering the terms to a calculator. Kasi nga naman, what if hinihingi sa atin na hanapin ang sum ng counting numbers, first 100 counting numbers, like 1, 2, 3 hanggang 100. Siyempre, kung iisa-isahin natin yan, na i-input sa calculator, di ba, ang tagal. But, meron tayong technique na pwedeng gamitin para mahanap yun. And that is, gagamitin natin itong formula for evaluating the sum of an arithmetic sequence. And our first term here, syempre ang ating smallest counting number ay 1. So, ang A1 natin is 1. And you see here, 1. And we end at n. So, yung term, siya mismo yung position, di ba? Yung second term, si number 2. Yung third term, si number 3. So, yung nth term, si number n. So, our a sub n is n. So, that's why this is n. This is 1 plus n. Or in other words, this is n plus 1. So, parang ganito raw ang gagawin natin. Kunin natin yung last number. I-multiply natin siya sa yung last number, dagdagan ng 1. O dun sa next. Parang ganon. For example, gusto nating hanapin yung sum ng 1 to 100. Take note, these are the first 100 counting numbers. O, ang gagawin daw natin, since our n is 1, si 100, si n is 100, i-multiply daw natin siya sa 1 plus 100. N plus 1, so that's 101. And then we divide the result by 2. And what we get is 5,050. So hindi natin na siya kailangang i-input pa sa calculator isa-isa. Dahil we have this formula already. The number, the n, yung dulo, the number sa dulo, times yung susunod sa kanya, that is 101. The result should be divided by 2. And then makukuha natin yung sum. So, we earmark this formula. And then, we will use it later. Now, meron properties yung sigma notation natin. Meron tayong ipipresent here na 4. The first one is the summation of terms with a common factor. So, this expression here means a constant times an expression. Tapos, ang pwede daw na ang gawin na lang natin is ilabas natin si constant. Extract natin siya. Tapos, ang gawin na lang natin is the summation of f of I, the expression, from I equals M to N. Kunin natin daw yun. Then, yung result, i-multiply na lang natin sa C. So, here's the proof. Pero diretso tayo sa illustration. O halimbawa, the summation of 3i from I equals 1 to 5. So, if we want to expand this I will write this in expanded form. That's evaluating 3i at 1 to 5. Then we get 3 times 1, 3. 3 times 2, 6. 3 times 3, 9. 3 times 4, 12. 3 times 5, 15. This is the expanded form of the expression at the right side. Now, this one daw is equivalent to, what if ilabas na lang natin si 3, the constant? Then, we evaluate the summation of I from 1 to 5. Or that is, we will replace this with 1, with 2, with 3, with 4, with 5. We add 1 to 5. Then, the result, we will multiply by 3. Pareho lang daw yung makukuha natin as dun sa nakuha natin dito. And, you may verify that na equal nga sila. So, that's one property of summation. May constant, pwedeng ilabas.